From my side, there's one word that we keep coming back to in Formula E, and that's efficiency. And it's not just efficiency on the racetrack, getting the most performance out of the energy available in the battery. It's efficiency as an organization. So for me, it's that constant worry about, are we being as efficient as we can? Are we spending our valuable resources in the right areas?
Welcome back to In Between Charges. My name is Kevin Spangenberg, and as always, I'm joined by Mike Cox. Mike, how are we doing?
Very well, thank you. Good to be back. I dusted off my frozen charging cable, just about managed to make it in, but otherwise all good. Good to be back in the warmth.
Happy New Year. We are mid-January now, so we're approaching the point when you can no longer wish somebody a new year because the new year is well underway.
Didn't you just wish me a new year?
I just did. I said we're almost there. We're not there yet.
Okay, good. This
Mike,
is the final.
We are back with our favorite Formula E team, Neo McLaren. And following our wonderful interview back in October with their team director, Ian James, we wanted to bring on two of their top engineers, Albert Lau and Chris Dyer, to dive into some of the most fascinating elements of Formula E, the vehicles, the charging, of course, and then the technology that is linking all of that together. So, gentlemen, Albert and Chris, thank you for your time. We appreciate that you're quite busy at the moment, I'm sure, as your season is getting underway. But thank you both for joining us.
You're welcome.
Great. So let's just dive straight in. Albert, you were talking about how you've been involved with Formula E for quite some time, seeing the evolution of the vehicles from Gen 2 down to Gen 3. Could you maybe talk about that progression a little bit? I was even reading where the tender's already out for the Generation 4 vehicles and everything. And back in Gen 1, drivers had to switch vehicles mid-race, right? And now, obviously, we're much further along with the power outputs and everything. So can you kind of talk about some of the technological changes that have enabled all the progression so far and kind of where it's going in the future?
Yeah, I mean, I think if you go back towards sort of the first generation of Formula E car, they were trying to do something that hadn't been done before, which was an electric race car championship. And the technology at that time, you're talking about probably 10 years ago now. So the batteries were sort of 28 kilowatt hours, and the output and the charge in the cars themselves are pretty limited in terms of, I think discharge power was 200 kilowatts, charge power was like 150 kilowatts. So from a pure vehicle performance point of view, not sort of nowhere near the levels of where we are today. And like you said, with such a small capacity battery, it was difficult to obviously complete these. They were trying to target sort of 45-minute races, and to get through that, they needed to actually do a swap of cars, which then obviously from a logistic point of view, getting twice as many race cars around the world in a championship, quite difficult. So the big step they made, so each of the generations last 4 seasons. So between season 4 and season 5, they moved to the Gen 2 car, which was quite a big step in that the battery capacity increased from 28 kilowatt hours to 52 kilowatt hours. So that enabled us to be able to do a full race distance without changing cars. And that was, for me, that was a big step. The car got a little bit heavier, but from a discharge and a charge point of view, those two things also improved. So the overall car performance took a reasonable step. But for me, that was mainly in the res and the battery. And obviously, from a team point of view, each team is making their own powertrains. And that side has gotten more efficient as well, which helps. And then from Gen 2 to Gen 3, from Season 8 to Season 9, this sort of past year, we actually went back down on the res capacity, on the battery capacity, down to 38.5. And the reason we were able to do that is because the charge power was increased from 250 kilowatts to 600. And now we're regenning from both front axle and rear axle, minimizing the use of the hydraulic brakes. So from a pure car performance point of view, again, you had a huge step in efficiency because you could actually then make a battery that was 100 kilos lighter, but you're still able to get the same amount of sort of number of laps and lap time. It's a massive step to be regenning on both axles and to add the performance that way and be able to do the same thing with a much smaller battery, which is, what we should be targeting, that overall efficiency.
Amazing. And just to clarify as well, when you say regenning, I assume you mean regenerative braking. So just for our audiences, so that is whenever the driver is essentially pressing the brake, slowing down, that energy is somehow passed back into the battery. Is that right?
That's correct. There's hydraulic brakes on the front axle and also a small emergency brake system on the rear. But in general, most of the energy done in deceleration is then translated back into the battery, which is, again, that's the gain in efficiency that we're talking about. So none of the energy is being wasted when we're decelerating the car.
Wow. I think we'll come back to that because also related to the inner workings of the vehicle just in the kind of second half. But what I'd also love to find out a little bit about, you mentioned the impact on the vehicle as you're essentially increasing the battery capacity. One of them is weight and one of them would then be handling of the vehicle. But what are some of the ways that you've adapted, or even the design of the car has been adapted to cater for that bigger battery size? Because I assume capacity will come with a factor of size, but do you use also modularity design? Is it a single pack that goes into the car? I mean, does that also vary between competitor groups as well? So the type of capacity that McLaren would have versus the other competing teams?
I can probably jump in here. At the moment, with each of the generations of cars in Formula E, the battery pack has been a single source component. So it's the same battery pack for all competitors. So in Gen 3 now, the battery pack we have is different to what we had in Gen 2, but it's the same for all the competitors. So the battery pack in our McLaren and our competitors is exactly the same. So a lot of the magic in Formula E and the differentiators and performance between the cars is how we use that battery pack more than the design of the battery pack.
Could you maybe go into that a little bit deeper? That was one of my questions was, well, Chris, you can definitely speak to this. There's quite a bit more standardization in Formula E versus Formula One, right? And so what are some of the ways that you're able to kind of differentiate when it's the same battery pack, it's the same tires, it's the same, a lot of the same elements? Where does that difference come and how do you separate yourself?
So there's three really key differentiators of performance. The first is the rear power unit. So the inverter, the motor, the gearbox that drives the rear axle is unique to each manufacturer. So in our case, that manufacturer is Nissan. They provide the power unit that we use. They also supply that power unit to their own internal team. So there are inherent differences in efficiency between those power units. It's not so much like Formula One where maybe absolute power is super important, because for us, the power is limited by the regulations. We all make 350 kilowatts at the rear axle. So the important thing for us is the efficiency of that PU. How much energy do we have to put in it to get the same performance at the rear axle? So that's the first performance differentiator. The second performance differentiator is really in the software. And this is where all the teams do their own software, or all the manufacturers do their own software, but all the teams do their own configuration of that software. And it's really the software that then has a very big impact on the overall efficiency of the vehicle. So it's how we choose to deploy the energy, how we choose to recover the energy. And then the other big differentiator is obviously the drivers. But driving a Formula E car is a very unique skill. I think you've got the natural need for drivers to be fast. That's unique in any form of motor racing. The big difference in Formula E is the driver's ability to manage the energy use. So they need to be fast, but they need to be efficient.
Amazing. Very, really cool. And I guess there's another factor maybe related to 3B, which is you said the skill of the driver, but I assume also the weight of the driver.
Well, the regulations specify a maximum weight for the driver and the seat assembly. So the idea is that if you've got a very small, very light driver, in order not to provide you with an advantage, you then need to add more ballast to the driver's seat.
Fascinating.
So every driver plus seat is in theory the same mass, although that's not quite true for all the drivers. Some of the drivers on their own are above that limit.
Wow.
Which means they then carry a bit of a penalty. But luckily, both of our drivers are below the weight limit, so we ballast their seat to bring them up to the weight limit.
That's fascinating. I think very interesting how many different parameters are tried to be controlled within Formula E. Maybe different as well to Formula One. I mean, could you tell us a little bit about why that is? Why are so many different parameters and vehicle parts and the weight of the driver, so you have to add ballast? Why is that controlled? Why is that something that's used in Formula E?
It's primarily two things. The first is cost. Formula E has a very close eye on the cost and how much it costs a team to go racing, to make sure that we have stability, that teams can survive, teams can be competitive because it's important for the championship. But the other really big driver is the show on track. By limiting the areas of development, you do limit the performance differentiators, which means when you hit the track, you have much more even performance between the cars. And you only have to look at where Formula One has ended up in recent years, where you go through periods where one driver, one manufacturer, two manufacturers dominate and they're winning week in, week out. There's a different approach in Formula E to try and make sure that nobody can dominate to the point of detracting from the show.
Oh, fantastic. Great answer. Thank you.
Monta, we are a charging software platform, so maybe we could talk a little charging, if that's all right. Maybe Albert, you can speak to this. So what is the charging like in the pit? I was also reading there's some updates coming to potentially, what's it called? Attack charge pit stops maybe as well. And maybe what is the intention of those? And so I know there's a lot of standardization regarding like the amounts that's charged, how often, et cetera. Maybe you can explain how that works for Formula E and what goes into the charging of the vehicles.
Yeah, so if we step back a little bit to the Gen 2 battery, obviously a massive step up from the Gen 1 one in terms of capacity, but the way we were charging it was still quite bespoke in that the sort of the connector to charge the battery was quite bespoke. We were still wearing protective equipment to do it. And the big step from Gen 2 to Gen 3 was to actually change the charging infrastructure so that would mirror more what is available sort of on the market for road cars. We now run a CCS connector as you would have on a normal road car. So because of that, you're then, from a safety point of view, not required to have things like protective equipment for that. And again, it's just pushing that side of the technology has improved a lot from the sort of road car market. That's actually found its way back into a race car, which I think is interesting.
Can we just also ask there? I mean, that sounds quite interesting, particularly from an innovation point of view. You're having to use safety equipment to be able to plug and charge the Gen 1 vehicles or the Gen 2 vehicles, right? Because of how the cables are set up, you don't have the right safety applied across the actual connector itself. So you have to kind of hack it a little bit. I find that fascinating.
At the time, it was obviously an innovative thing to have a battery of that size and to be able to deliver the amount of power from a race car point of view and make that race sort of signed off for a race car. Where obviously they're taking lessons learned in that and able to adapt some of the technology from the road cars into this now. So I think that was a good sort of other way of technology transfer. But the next step for us is attack charging, which is set to debut this year in season 10, which is leveraging the charging capacity of the battery itself. So the battery is rated to be charged at 600 kilowatts. That's what it's doing on track normally when it regen brakes from the front axle and the rear axle. But now we're going to utilize and leverage that limit in a pit stop scenario where we're going to connect what we're calling a boost charger, which is able to deliver those 600 kilowatts over a mandated amount of time to increase and charge the car in, let's say, in a fast charging point of view, faster than anything we'd have on market, let's say.
So I guess there's loads of different channels into innovation from, the race to road, which I think is quite a nice way of kind of talking about it. What type of cycle time do you tend to see with these types of technologies before they are adopted in the actual classical manufacturing line of, let's say like the Nissan Leaf, for example, whatever it might be, or even the hybrid vehicle the McLaren has recently manufactured and basically put out to market too? Is there a set time that you see it takes to be adopted, and how long would you see that adoption time for something like the 600 kilowatt or the high-powered, super high-powered attack charging strategy?
That's a question beyond my limits of understanding.
How long's a piece of string?
You have to remember that the battery in the race car is a dedicated res that's designed to be charging continuously on racetrack at 600 kilowatts, which from a usage point of view is not necessarily going to be the case for most road car cycles. So that has to be taken into account as well. But
I can picture it all the way down to mobility scooters. Let's attack charge my Tier mobility and head to supermarket.
You're making a lot of assumptions about our driving habits. And I think everybody drives a little bit differently. So, for certain people that could be useful. But, no.
I love it.
I think what they're doing with that just opens the eyes to sort of what is possible. And then from there on, you sort of can work out the details. Once you've seen that it can be done, then I think it's a little bit more easy to translate that into a more automotive use. But that's going to be something left up to the various OEMs in terms of how they feel they can leverage faster charging technologies.
And then when the E-Prix goes to the US, do you need to use the North American charging standard? You have to switch over to that? Or?
Yeah, it takes twice as long.
You've touched the nerve there. North Carolina is off the next series.
Yeah.
Interestingly, our attack chargers are powered by another battery.
Oh.
So it's battery to battery charging.
Okay.
So it's kind of like driving your road car home and plugging it in at your house, and then your house battery then charges your car battery.
Okay, a regulatory loophole. Nice.
Kind of a question. I was reading about the Neil McLaren team earlier, and I saw that this past summer, the team used AI to generate the livery or liver. I'm not quite sure how you pronounce that. The wrap, I guess, basically of the vehicles for this summer. And it was the first AI produced wrap for a vehicle. Obviously, that's kind of more of an aesthetic appeal kind of piece. But are you using AI? Is it filtered into kind of your team? Are you using it for software updates, or is it kind of still kind of off the track? Or is there any way that your team is employing AI to improve your performance?
There is.
But you can't tell me?
Look, we have some limited applications at the moment. We have to be very careful with these sort of new technologies to make sure we apply them in the right areas. So one of the things that's always interesting for us is to make sure we're aware of these sorts of technologies, to try and gain a little bit of understanding of them, and then try and understand, do we have an application that might be suitable? So it's very much an exercise of understanding a little bit about the technology and then looking around at what we do and trying to decide whether there are good applications for that technology. You don't automatically take reinforcement learning and then say, right, let's apply this to every problem we have. So it's very much, we need to evaluate, we need to look at the applications, and then we need to choose the right tool for the job.
And maybe then, just so I understand, because I definitely appreciate there are components of McLaren's strategy that you want to keep confidential, because I assume the relation is because you mentioned software is one of the strongest ways that different teams can differentiate themselves in a competition. Is that right? Could you also maybe explain a little bit more as to, does that also have implications for McLaren broadly? You have Neil McLaren Formula E, and maybe there are some applications to other types of powertrains that you're trying to develop, or is it purely related to Formula E?
Look, we're part of McLaren Racing, and we take part in a number of different series, and we're always looking for ways we can leverage our resources across series. So we're keeping an eye on what's happening in the other series that we're involved in and trying to understand what we can learn from our other teams, what we can share with our other teams, areas we can collaborate to try and get the maximum value out of all the resources we have available.
Amazing. Perfect. Thank you. Okay, we haven't talked about tires. Tires was one of the topics I thought you were very interested.
I am interested in tires, actually, but it's maybe slightly less interesting in the case of Formula E because you're using the same tire, right? Or maybe you could speak to that a little bit. Is that the case, or is it changing? What I was able to understand is that the same tire is used by every team on every track, regardless of the conditions.
Yeah, that's right. So it's a single specification tire that's able to drive in the wet, it's able to drive in the dry, and I mean, we only have the sort of two sets for every race weekend. So from a pure tire usage point of view, it's much more sustainable than a lot of other sort of motorsport championships. But because of that, we just have to focus on the one tire and learn as much as we can and just see how that works in the different conditions, different tarmacs, different surfaces, and things like that. So there's a lot of work that can be done. And it's still the only 4 bits that touch the ground. So it's very important.
And it's much more relevant to the real world and to road car applications than most other forms of racing.
Yeah, fantastic. Okay, so you have 2 drivers, is that right, per team?
Yep.
And you have the Gen 3 vehicle now. You have the software that you need to make sure is as up to date as possible to ensure efficient running of the car, but also connecting to other processes within the car that will help you to get essentially longer and quicker within the race. So the regenerative braking, for example, how much energy is actually being put out to the vehicle as well as the wheels are turning around a corner, etc. How fast is the driver's reaction times to be able to do it? Lots of different things playing into whether a driver is 5 seconds ahead, 10 seconds ahead, 15 seconds ahead, or even needs to come into a pit stop a few minutes before, and that can be game changing. But in your role as an engineer, whether you are trackside or whether you are in the actual factory side, working with the actual vehicle line, etc., what is it that keeps you up at night? What are some of the things that really keep you going and try to keep McLaren ahead of the other competitors?
I think from my side, given the pace of development from a software point of view, there's a fine line between pushing for a lot of development and then process for ensuring that everything is as robust and works as per expectation. So there's a lot of work that's done every time software is released, from how we check it in hardware in loop, software in loop, driver in loop simulations. But there's always going to be perhaps an odd case where the inputs are different enough to the software where maybe the output doesn't exactly match your expectation. And it's those sort of edge cases that would keep me up at nights, to be honest, sometimes, just because there's a little bit of uncertainty there. And because of the pace of development, we're changing the software so often, you hope that your processes are good enough to capture all of these things. But there may be the odd thing that happens that you've never seen before on track, but that makes the software react in a different way than you're expected. And that kind of keeps me up at night sometimes.
You don't have the luxury of having a long QA process there?
No, not in racing.
Chris?
From my side, there's one word that we keep coming back to in Formula E, and that's efficiency. And it's not just efficiency on the racetrack, getting the most performance out of the energy available in the battery. It's efficiency as an organization, and we operate under a very tight cost cap, so all the teams are allowed to spend exactly the same amount of money. So for me, it's that constant worry about, are we being as efficient as we can? Are we spending our valuable resources in the right areas? Which areas of the car, which areas of the team, which technologies, where do we need to be focusing? And that's not a static target. So depending on how things are going on the track, how our competitors are evolving, that needs constant review to make sure all the time that we are working as a team in the most efficient way possible, so we can get the most efficiency out of the car, and that gives us the maximum performance on the track.
Amazing. Maybe as a follow-on to that, for McLaren, you mentioned there are various different, it's a moving target, but then what does success look like in application of that investment for Neon McLaren? Is it about position in the final as you're crossing the finish line, or is it about road applications, or is it about volume of deployed, like successfully deployed updates, basically? I mean, where's the real value and how do you measure success for Neon McLaren?
Well, we're all racers.
Right.
We want to win. We want to win races. We want to win championships. You're speaking to a couple of engineers. Perhaps other parts of the organization might have a different perspective, but for us, it's winning on track and winning championships.
Amazing. Pure racers. I love it.
All right, so the 2023-2024 campaign is right around the corner. What are the biggest changes, upgrades, modifications that we can expect to see on the track?
So I think the biggest open point at the moment is with the attack charge. That's going to change the nature of the races quite a bit. So that's going to be a real steep learning curve for everybody. And some people will adapt faster than others. And the people who adapt fastest will take the initiative in the early part of the season, and the other teams will be catching up.
Interesting.
It represents a significant change from how we go racing. Once you return a pit stop to the race itself, there's going to be new software that can be written to help the driver when he's coming in to do his pit stop, how the team's managed from a strategy point of view, again, from the mechanics point of view, how they're actually practicing charging the car itself. It's actually one element in the racing in season 10 that's going to affect everybody across the board. It's not just an engineering exercise, it's an operational exercise, it's a strategy exercise. So that's the thing to look forward to this year. That's going to make a big difference, as Chris said.
Amazing. I don't think there's another sport, or maybe even like motorsport out there, that is developing as quickly as Formula E. I feel like every year there is some sort of significant change which really changes how the race is done. It changes the urgency, basically, of the skill of the driver and the vehicle. And we're literally seeing a maturing motorsport unfold in front of our eyes every year.
Yep.
Great. All right, one final question, and then we'll just do kind of short wrap-ups. We like to end every episode with the same question, and that is, if you were to bust one myth about EVs or Formula E or EV charging, what would that be?
So I've been driving an EV for many years, and overall it's been a great experience. And I just invested in the second EV, and unfortunately it's got a different charging plug on it to my first one. So at the moment I can't charge the second EV at home. And I'd thought all along that an EV is a great idea when you've got a charger at home, but maybe especially here in the UK at the moment, it's probably pretty difficult to manage when you don't have a charger at home. But I'd have to say that the situation has changed quite dramatically. Now I've got an EV with a much more sensible range, and I'm charging it using public charging, and actually it's been quite a surprisingly pleasant experience.
Oh, wow. So the myth is you don't necessarily need a home charger.
Correct.
Cool. Thank you. Albert?
I think from my side, I'll focus more a bit on the racing side. Ultimately, especially in our championship, the focus has always been, a lot of people focus just on the pure lap time of the vehicle when they look at the different generations of cars. Then they start comparing lap times with F1 and things like that. But I think the thing that's missed is actually the efficiency in what we're doing. You know, when people started seeing the specifications on the Gen 3 car, for example, it was very much like, oh, what is the lap time compared to the Gen 2? Or what is the lap time compared to the F1 car? And I feel like we're kind of missing the point a little bit in that we've taken such a mammoth step in efficiency in this latest generation, but not enough people are talking about that side of it. They just focus purely on the speed, which I get. I mean, it's motorsport, it's still racing, but at the end of the day, our sport is about efficiency and doing as much as you can with a finite amount of chemical energy in the batteries. And I think that's the thing that people don't talk about the most. And I think that needs to be brought to the forefront rather than just all the other parts of the racing.
Great. So we need to be talking about the efficiency more. The myth is Formula E is all about speed, and that's not true. There's so much more to it.
Yeah. It's a very tactical, strategic sport, not just about trying to kind of push through hardest speed at any one time. It's really being conscious of how you are using the brakes, turning the corners, pressing the accelerator, everything. Fantastic.
Great. Well, Chris, Albert, this has been a real pleasure discussing all things Formula E with both of you. So thank you so much both for coming on the show.
Thank you very much.
Having us.
Thank you for being interested in our world.
And that'll do it for today's episode of In Between Charges. As always, this is brought to you by myself, Kevin Spangenberg, my co-host Mike Hawks, and our producer, Rocio Fortuny. Make sure to follow Monta on all your socials, LinkedIn, Facebook, Instagram. We could use a few more Instagram followers.
Tell your friends.
Tell your friends. Leave a rating on Spotify or podcast. We still have a perfect 5-star rating on Spotify. Help us keep it that way, and we'll see you soon.